Now the next question is the number of all 4-digit numbers that can be formed by using the digits 1, 2, 3, 4 and 5 and which are divisible by 4. Now friends, what's the divisibility test of 4? The last 2 digits should be divisible by 4. So first of all, from these 5 numbers we have to make the various combinations of the digits or numbers which give us the last 2 digits as divisible by 4, right? Suppose example 12, then no other combination from 1, then let's take from 2, so it's 24, right? From 3, 3 1 is not there, 3 2, then 5 2, then we have 44 as well, because digits can be repeated. Since it's not given there that the digits cannot be repeated, so we can take the repetition of digits as well, right? So in all, these are the combinations where the 2 digits are divisible by 4, right? Now what? These are the last 2 digits. So the remaining 2 digits, because we just have to form the 4-digit numbers, the remaining 2 digits in how many ways we can fill, that we have to calculate, right? So suppose it's this. So the remaining 2 digits, for each place we have 5 choices, that is 1, 2, 3, 4, 5. Any of the number we can fill up. For the second place as well we have 5 choices, and the last 2 places are 1 and 2 only, right? So for each combination we have 25 ways. Okay, 25 numbers when the last 2 digits are 1, 2, 25 numbers when the last 2 digits are 24, 25 numbers with the last 2 digits as 32, 52 and 44. So in all 25, 25, 25, 25, 25. That is 25 into 5. In all, there will be 125 numbers, 125 4-digit numbers which are being formed by using these digits and which are divisible by 4, right? So I hope you are clear. Quite a good problem. Now let's see this problem. Total number of numbers greater than 100 and divisible by 5 that can be formed using the digits 2, 3, 5, 6, no digit being repeated. Now if we don't want the repetition, that means at max 4-digit numbers can be formed, right? And we have to make the number greater than 100, that means 3-digit and 4-digit numbers we have to form. And if the number is divisible by 5, that means among these digits the unit place should be occupied by 5 only, right? So first of all, let's calculate the 3-digit numbers. Now at the units place we have just one choice, that number 5 will be there, right? For these 2 places, since we don't want the repetition, we have to select the number from these 3 digits, right? So 3 digits, from the 3 digits 2 numbers we have to select, and these 2 digits or 2 numbers which we are going to select can be arranged in 2 factorial ways, right? So how many numbers will be there? It's 3c2 into 2 factorial. So precisely it is 3 into 2, 6 numbers. Or since the options are in C and P, so this is what 3c2 into 2 factorial is nothing but 3p2. So this is what the 3-digit numbers, right? Now let's take 4-digit numbers. So the condition will remain same. At the units place we have just one choice, that number 5 should be there. For the remaining places we have 3 numbers and 3 arrangements, 3 factorial arrangements, right? So we have to select 3 numbers out of 3 and arrangements will be 3 factorial. So precisely it is nothing but 3p3. So it's 3p2 3-digit numbers and 3p3 4-digit numbers. So in all 3p2 plus 3p3 total numbers, right? So 3p2 plus 3p3. This is the correct answer. Now we have been given this option also, this particular option. But if the student forget that the arrangement will be 2 factorial and 3 factorial in these cases, he'll ending up marking with this option and there will be an error, right? You have to be careful that where to arrange, where not to arrange, right? Because if you select two numbers, that till here it's just selection. If you select two numbers, that is 2 3, so from 2 3 you get a number, and from 3 2 you get a number, that is 235 and 325. Both the numbers are different, so we have to count them two numbers, right? So if you are not making the arrangement, you are making a mistake. So be very, very careful about it, right? Let's take the next problem. Now friends, let's see this question. This is from CAT 2002. If there are 10 positive real numbers, n1 is less than n2 is less than n3 is less than dash 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 till n10, that means there are 10 numbers, and they are written in ascending order over here. How many triplets of these numbers n1, n2, n3, n2, n3, n4 can be generated such that in each triplet the first number is always less than the second, and the second number is always less than the third? That means n1 is less than n2 is less than n3. That means the three numbers are written in descending order, right? So a simple conceptual problem. See, we have to make the triplets, and we have to select the three numbers from this 10 numbers. So how many ways we can select? 10C3, right? Now we have to make the arrangement where n1 is less than n2, where n2 is less than n3, right? So it's just a single arrangement is possible if we have three numbers. Suppose we chose the three numbers as 3, 7, 2, right? So in how many ways we can arrange them? So where the numbers are in ascending order, that will be just a single arrangement, that is 2, 3, 7, right? So we got all the combination of three numbers from these 10 numbers, and there is a single way of arranging these three numbers, that is the ascending order, right? So whenever we want to arrange the number in ascending order, it's just a single way, just a single way, right? If the numbers are fixed. So 10C3, the total combinations are there, and arrangements will be one only. So in all, 10C3 is our answer. Now 10 into 9 into 8 by 3 factorial, that is 6. Or we can say 3 into 2. So it's 2 4s are and 3 3s are. So 3 4s are 12 into 10. In all, there will be 120 sets, or we can say 120 triplets, right? I hope you are clear. Further, we have done good number of problems, in fact difficult one problems in this session. We'll be taking more problems from the previous year CAT papers and previous year like other examination papers. So let's meet in the next session once again. Bye bye.